I'm the group leader of the project. In this project, I was mainly responsible for 3D drawing and sorting out various parameters of parts. For example, the selection of materials, the analysis of parts, and the final paper writing and sorting. Thank you.
Hello, my name is Noah, and in this project, I'm responsible for the process of the all parts and the grain manufacturing process as well.
Hello, I'm Vikram. In this project, my part was the stages of the processes such as forging and machining and grinding. So I will talk about those things.
Hello, my name is Islam. So in this project, I'll discuss about introduction, then analysis of piston machine process, the competitors present locally, and federal corporation.
Hello. First is my part, the specification and the detailed specification. Hello, this is the cover of our PowerPoint. I divided it into 4 parts: the detailed specification, and 2 is introduction, 3 is stages of the process, and 4 is manufacturing, green manufacturing. First one, detailed specification. It contains material selection, component analysis, dimensional surface, and specification, technical drawing. This is a 3D drawing of our component. And this is a parts list. It contains 10 components, and this is a material selection. I make a vivid analysis for all these materials in the report. This is the technical drawing. This is for the master rod. This is for the architected rod. This is for the piston, and this is for other components.
So my name is Islam. So my part is introduction, the method of production. Introduction. So in introduction we can discuss the method of production, assumption on the type of manufacturing system, assumption on the quantity of production, product cost estimate, the historical development of this product, the competitors present locally. So as a complicated and expensive equipment, the piston and piston rod of aircraft engine cannot be used in mass production due to the small market demand, which is not enough to support mass production, large scale production. Moreover, due to the complexity of this process and this particularly of the materials, the production method of JOB shop cannot be used. At present, batch production is mainly used to change the part. To assumption on the type of manufacturing system, analysis of piston machine process. The piston manufacturing technology of internal combustion engine has been developed in China for more than 40 years. More and more countries have mastered and developed this technology. The competitors present locally. Now most of the piston manufacturers use special customized machine tools and general lathes. Special customized tooling and feature composed of the single machine assembly line production. Pipeline equipment is arranged as one machine, one sequence, or one machine, multiple sequence. The flow is longer. This last is the historical development of this product. So the historical development of this product at early years, the engine don't have piston. They only can do the linear motion. So if there isn't piston, the cars don't develop today. There wouldn't be so much transportation. Then the pistons begins to appear. The pistons have its own structure. Both ends of these pistons are closed. The rod passes through the center, but the joint is tightly scaled. In gasoline engine, one end is open to allow swing of the other moving parts in this engine.
I will introduce some process easily. First is the master rod. We select the casting. The details of the casting we can learn from the internet. After casting is the machining operates. The function of the machine is to correct the dimension. Almost all of the machine operation is the same function. Then is the grading. Most of the parts need to grading to increase the using life. The sixth part is the articulated rod. Its manufacturing process is the same with the master rod, except increasing the process of heat treatment, which is to increasing the mechanical properties. The pros of the piston are totally same with the master rod. Other parts like piston pin, because its value is small, so we can directly use the machine to produce. After machine, sometimes we need to grinding. That's all.
Hello, I'm Mahmoud. So here in this project, my part was to describe the stages of the processes. So basically our component was a radical engine assembly. So now I'm going to describe all the processes step by step. So for the master rod of the component, there are two processes like heat treatment and forging. So for heat treatment, billet is heated in the furnace at 500 degrees Celsius to 600 degrees Celsius, and in forging process, hot forging is defined as working a metal above its recrystallization. The main advantage is that as the metal deforms, the strain hardening effects are neglected by the recrystallization process. And there's another process, and there is machining operation. Cut off excess dimensions, grinding the side faces to increasing the using life of the parts. And then another part is articulated rod. So there are some few processes we can use here. There's, like you can see here, it's casting, machining, grinding. So for this articulated rod, we will discuss about the forging process. Due to the common structure of the hinge rod, the die required for forging is simple and can be produced very fast. For machining process, because the process of forging is matte, so the size is not accurate. It needs secondary processing of machining to ensure the suitable dimension. And then we'll talk about grinding. After the process of machining, the part has accurate size in order to better useless performance. We can grind the surface and make it more smooth. And for piston, we can follow three processes. Same again, it's casting. The piston is small and the internal structure is more complicated. The casting of the piston is a skillful job, especially when the mold is completed. It is complex because there are many vent holes and air inlet holes. And for machining, because the product is usually bigger than the actual size, because the casting process is to the approximate geometry of the product. If we want to get the final product, we have to do subsequent processes. The machining operation is to make the product closer to the actual size. Then let's just talk about the grinding process. To build the piston, then in order to increase the quality of the products and promote the using life, grinding is necessary. Then we can just talk about a bit about the machines. These productive machines got both economic and technical solution. These machines are energy saving and eco-friendly. They are low cost maintenance. They have a high output, high rate of machinery uptime, and maximum process reliability. So that's all.
During manufacturing process. In the manufacturing process and a symbol of a piston, invariably there will be heat loss. If there are many processes and the processes are not very suitable, the loss of heat energy will be very large. So reducing the loss of energy is so important for green manufacturing. In order to decrease the loss, so we can apply a system which is designed for thermal dissolution. Based on this thermal dissolution system, the heat energy loss gets effective improvement. According to the simulation and analysis, the effectiveness increased about 15%. In addition, 3D print technology can be applied to the casting. For example, when we make the core of the model, if the structure of the model is difficult, we can use the 3D printing method to make the model. We just need to build the model of the parts. This method can decrease the consumption of the sand, but also avoid the phenomenon of increasing the particulate matter in the air. Dry cutting is so important in the manufacturing process too. In the process of machine, we must avoid the tools and the parts wouldn't be overheated. So in traditional machining process, we must add the cutting fluid, but usually most of the cutting fluid are harmful for human and the environment. At this time, the dry cutting method seems particularly important. That's all.
Okay, let me give a small conclusion. After a comprehensive consideration of the product performance, durability, production cost, sustainability, production efficiency, and other aspects, we finally believe that Plan 1 is the most suitable production plan for this part. Under the conditioning of ensuring the basic performance and life of the products, thanks to the modern developed equipment manufacturing industry, this scheme can reduce the production cost and shorten the production cycle to the maximum the extent, and also conforms to the principle of the environmental protection and green production.
In this project, I learned a lot because everything needs us to do by ourselves. If something we don't know, we have to find it from the internet. At last, I really thanks for everyone's hardness. That's all.
From this course, from this manufacturing course, I learned a lot of things. It's increased my experience, and I think it's useful in my future life and job life. So I know from this course the machine language, how to actual manufacturing the product. So I think I learned a lot of new things, what I don't know before. So I think it's a very great experience for me. Thank you.
So from this course, before doing this project, we just learned in the classroom about manufacturing processes like machining, forging, and casting, all these stuff. But when we started this project, then we get to know about what the real use of these processes in our real life. So our project topic was radical engine assembly. So when we research on it, then we get to know how it works in real life. So we get to know how forging, how machining works when we make a real life stuff. So then again, we know about the machines that being used for making these components of this stuff. So we get to know that the sustainable solution when making component So that's all. So that project was very useful for all of us, and everyone had a great effort on it. So I'm especially thankful to all my friends. That's all. Thank you.
Actually, I have a lot of feelings about this project and the process. Thanks for the opportunity, so I learned a lot of professional knowledge, and especially for the performance of parts materials. The impact of manufacturing process on performance had a deeper understanding. I do a lot of mistakes that make our project cannot done well. So, but this is the first time I become a group leader. So, I think in the future I will be better, and I will try my best. Thank you.